In this example problem, we have a data set that has 32 students from a class of elementary statistics that they took. We have 2 points of data that are pertinent right here, what each student got on their midterm and which grade each student got on their final. And what we're going to do is we're going to do some regression to see if a student's midterm grade had a significant impact on their grade on the final in the course. We have 4 points that we're looking for. Firstly, we need to establish what our regression equation is, what equation we're going to use to help us predict, based upon one input, what another output will be. With that formula in place, we're going to make a prediction for the final score of a student who scored a midterm of 80. And we're also going to find a few points about how accurate what is the veracity of our data, how accurate these predictions are. We're going to figure out what the standard error of the estimate is and what the coefficient of determination is. So let's get started by first analyzing our information. Just like we did before, I'm going to use the data analysis tool pack one more time. We are still doing regression in this instance. And we need to input in our variables in a way that's going to help us predict one from the other. X makes Y change. What we're asked to do here is to figure out what the estimated final score is based on midterm score. So we're saying that midterm is what's going to dictate how our final score changes. So our Y range that we have is the grade on the finals. I'm going to grab the entirety of that information. Our X range is the entirety of midterm scores. Clicking on the header and hitting Control-Shift down to grab the entirety of that information. I have our labels selected within our range, so I'm going to make sure I have the labels button on, and then our outputs that I want is going to go into cell whatever we want. It's going to give us an easy spot to look at the information. I'm just going to put it right here in E11. And I hit OK, and I get my summary output of that regression. And what that regression is telling me, in this case, down here, is that our baseline is at 27.58. Essentially, a student who got a 0 on the midterm would be expected to get a 27.58 on the final. But the slope, the coefficient for our midterm grade, is that for every point a student scored on the midterm, it should increase the grade on the final by about 2/3 of a point, 0.6773. Well, I can put that into equation form, because what I'm saying right here is that the baseline of our regression equation is that it's equal to what somebody would get having either got a 0 on the midterm or not taken the midterm at all, 27.58 and change, plus an extra 0.677393 for each point that they score. And this is in equation language. Y hat equals A, which is our coefficient for our intercept, plus B, our coefficient for our first X variable we have, in our case is midterm, times X, the amount of X that we are predicting for. So here, one more time, our equation is saying that a student will get 27.5 points, essentially, on the final with no information from their midterm. But for each point they scored on their midterm, the predicted final grade on the final exam should be about 0.677 points higher. So down here, for my estimated final for a midterm score of 80, what we're answering in part B over here, I can just fill in this equation. It is equal to A, that 27.58 and change, plus B, that 0.677 additional points we get for each midterm grade, each point on the midterm, times X, the number that we're testing for. And we're looking for a student that had a score of 80. So my equation is this plus this times that 80 we're looking for. And I throw it in, and I get 81.773, etc. So if a student got an 80 on a midterm in our class, it's projected by our regression equation right here that their score on the final should be a little bit underneath 82. Pretty useful for determining, if your scaffolding knowledge, if you're helping students build up so their grades increase during the period. We have a small increase right here, but overall pretty consistent scoring. A student got an 80 on the midterm we'll get approximately an 80 on the final, maybe just a smidge higher. But how accurate is our prediction? Well, we've got two things we can look for. The first being the standard error. There's a column over here that says standard error, which is the standard error for each variable that we want. But it's not the standard error for the regression equation that we created as a whole. That guy can be found up here in regression statistics. So our standard error for the estimate is 14.94, a little bit under 15 points, which means that we are accepting in this case that our prediction may be off by up to 15 points, higher or lower. That's a pretty big range right there for all of you students out there. 15 points less than an 81 is not a grand grade. 15 points above an 81 is an exceptional grade. So is this really helping us out? Is this predictor variable that we're using, the midterm grade, really having that much of an effect on our response variable, the final grade? Well, that is the coefficient of determination. And we're going to look in the same spot that we did over here, because this is the output of our statistics for the entirety of our regression equation. And there's two of them here. There's R square and there's adjusted R square. When you're making a prediction based upon just one predictor variable like we are for a midterm right here, you want to use the regular R square. The adjusted R square is used when you have multiple predictors in one equation that gives you one output for Y. But for us, since we only used one input, one predictor variable, we want to use just the regular R square, which is 0.304464004. Well, what does that mean? Well, in this little box over here, I'll type in exactly what it means. That coefficient of determination says that 30.45% of the sample variation in final grades can be explained by this regression equation. See, there's a lot of factors that go into what you get on a final score besides what you had on the midterm. There are instances where a student won't score particularly great on the midterm because they didn't study a ton, realize they need a big grade on their final score, on their final exam, and study a lot in that case. Well, in that case, what we're saying is the final score is predicted more on study hours than it is what they had on their midterm. There's external factors in life that happen as well. I mean, you could have a situation where work made you work extra hours when the midterm was going on, but now your schedule is easier during the final exam, so you have more time. So work hours could be a predictor variable for final exam. There's a bunch of factors that go into an output, not just one, but all of those different factors add up to 100% of the reason for the output that you're getting. And what this implies right here is we're only capturing just a smidge over 30% of that. Only 30% of the variation that we have in final grades can be predicted by extrapolating information based upon a midterm grade. The other 70-ish% comes from something else. Is that a bad number? Not really. It's not a great number. Like if it was 90%, I'd be feeling really confident in this case. But 30% is not insignificant. It's a definite, reason for final grades going up. A student that does well on the midterm will tend to do well on the final. As you can see right here, the students that got 100 also had a 95, 89, and 99 on the midterms. There's definitely a correlation between those two. But it's not everything. There are instances outside of this. So while it is a factor, the correlation between midterm grades and final grades is a little weak. A whole bunch of other things besides that go into dictating what a student's final grade will be.